When we're adding and subtracting complex numbers, what you have to remember is it works just like combining like terms. Only terms that have an I can be combined with other terms that have an I, and constant terms can be combined with other constant terms. So for this first one, we've got a 5 and a 6, and we can get rid of the last set of parentheses. We can, distribute this plus sign, but that's not going to change anything in terms of our signs. So we would have 5 plus 6, which would give us, actually I'll just write it out, and then we would have, I take that back, not equals, and then we would have plus 3i and minus 10i. So I'm just rearranging the terms so that the like terms are next to each other. 5 plus 6 will give us 11, and a positive 3i and a negative 10i will give us negative 7i. And we're done. So now let's look at subtracting. So here we have one complex number subtracted from another. And this time, since there is a minus sign in between them, we're subtracting, we have to distribute that negative to each of the terms in the second set of parentheses. So we'll still have 7 plus 2i in the first set, but then a negative times a negative here will give us a positive 8, and then a negative times a positive here will give us a negative 5i. Then we combine our like terms. We have a positive 7 and a positive 8 will give us 15. And then we have, with our I terms, a positive 2i and a negative 5i will give us negative 3i. And that's it, because since they are not like terms, we can't combine any farther. So that's our answer, 15 minus 3i. All right, we've got one more, and this again is subtraction, so we're going to have to distribute again. We're going to start with 9 minus I, that's what we've got in the first set. Then a negative times a positive 2 will give us a negative 2. And a negative times a negative 13i will give us a positive 13i. All right, we're going to combine our constant terms. We have a 9 and a negative 2, which will give us 7. And then we'll combine our I terms. We've got a negative I and a positive 13i, which will give us a positive 12i. And that's where we stop. That's the end. So adding and subtracting is pretty straightforward. It's just like adding and subtracting when we've got like terms. All right. So now let's look at, we're adding and subtracting again, but this time our numbers are not written as complex numbers. We have to get them there first. So let's start with the negative 20. If I do the square root of negative 20, now you would recall from the last lesson that I can rewrite this as the square root of negative 1 times the square root of 20. The square root of negative 1 is I, and to get the square root of 20, I can either do a factor tree, or I can think of the largest perfect square that goes into 20. So my perfect squares, my first one is 1. That definitely goes in. My next perfect square is 4. And after that, 3 times 3 is 9, doesn't go in. 4 times 4 is 16, doesn't go in. So 4 is my largest perfect square. So we could write it like this. Right? So I'm breaking 20 up into 4 times 5. And the reason I'm breaking it up that way is because 4 is a perfect square. So then I know that the square root of 4 is 2, so I would have I times 2 times the square root of 5. And when you have these three different types of terms all multiplied together, we always write the real number first, then the imaginary number, and then the radical. So we can replace this. So far we've got a 4 out in front times 2I radical 5. All right, now let's look at the 125. Negative 125. Now you may not be able to think of the largest perfect square that goes into this right off the top of your head. If you're thinking quarters and dollars, you might get it faster, but let's do a factor tree just in case. So if I do a factor tree for 125, that was 5 goes in for sure. And then 25 I can continue to break down into 5 times 5. And if you remember from the previous lesson, every time you have a pair that comes out in front, oh actually hold on, let me break this down into -1 and 125. So every time we have a pair that comes out in front, and what's left over with no pair stays on the inside. So there's the factor tree method, and then this of course is I. So now I just rewrite it, just reordering the terms. I've got my 5 first, then my I, and then my radical 5. So I'm going to come over here and put that in here. Now I need to multiply the 4 by my 2 because they're both real numbers. We can only multiply reals times reals and imaginaries times imaginaries and radicals times radicals. So 4 times 2 would give me 8 I square root of 5 plus 5 I square root of 5. And the only reason, right, listen to this closely, the only reason I can even keep going here is because they both have the same number inside the radical, so the same radicand, and they both have I. If I did not have both of those things, I could not continue. I would have to stop here and I would be done. But because they both have an I root 5, I root 5, I can combine them and get 13 I root 5.